Okay, so part of the reason 7.1 was so long is I taught you most of the stuff in 7.2 as well, so that's good news. We already taught this, we already taught this, already taught this, already taught this. So this is new. Okay, so interest can be continuously compounded. So there's a special formula. The other formula we learned the other day will not work if it's continuously compounded. You have to use this formula. E is a button in your calculator. We'll talk about that. It's not a variable. It's a 2.718, kind of like pi. It's an irrational number. So let's just apply the formula here. All the notations are the same abbreviations what they meant before. So this is A is the amount. So the amount after t years. In this case, it's 3 years. The amount after 3 years. Principal is the amount you invest, 1,000. E, again, is not a variable. It's a number you type in your calculator. It's a button for that. To the RT, so R is always written as a decimal. So 0.12 times time, which is time in years, which is 3. So you type that into your calculator. So get your calculator out, and we're going to go 1,000 times. You see this E to the X button right there? So if you click that one, E to the power of 0.12 times 3, right? In the exponent is 0.12 times 3, rate times time. So E is just a number, 2.7. So calculate, give us an answer. So you're going to have $1,433.33 rounded off. That's pretty nice, right? Because we had an interest rate of 12%. That's insanely good interest rate. So that's really pushing the envelope a little bit with interest rate. Okay, we'll use this calculator again in a minute, but let's just figure out which formula we need for which problem. So continuously compounded, you need the A of t. The one we just did is P times E to the RT power. If it compounded semi-annually, that means the N value is equal to 2. That's how often it's compounded. And that's going to be, the formula is A of t equals P times, if you remember it from the other day, 1 plus R. Oh, guess what? This formula is a little more complicated. So you'll need a new formula when N is not 1. So that's the difference in this. So if N is 1, you can use the old formula. The old formula still, this will replace the old formula, which still works if N is 1 as well, to the power of NT. Okay, so N is, I've not written that yet. N is how often it is compounded. The interest is compounded. So if N is semi-annually, that's twice a year. Quarterly would be 4 times a year. Monthly would be 12 times a year. Daily would be 365 times a year. Trying to think of other ones. Any number you can plug into this formula. So this formula works even if N is 1. It's really the same formula. You remember the old formula was A of t equals P times 1 plus R to the N. Well, if N is 1, that's this formula like that. Well, if N is 1, you'll have that. That's to the power of t there, I think, actually, in that old formula. And you'll get that exact problem. So N is how often it's compounded, so it's not just once a year, so we need this more complicated formula here. So there's really 3 formulas, or if you only want to learn this one can replace this. This was unnecessary. You just have to plug in 1 for N. Okay, so if it was yearly compounded. So A of, we need to figure out how many years and stuff. So let's say we have 10 years. And let's say we're getting, let's see. Okay. And let's say we put $1,000 in. So $1,000 we invested. Okay, so A of 10, A after 10 years equals 1,000 for both problems. We're doing those, by the way. 1 plus the rate is 0.05125 over N, which is 2. It's compounded twice a year, to the power of 2 times 10, which is N times T. You can type that in your calculator, get an answer. We'll do that in a second. This one is going to be the principal, 1,000, same principal, times e to the power of rate, which is, in this case, it's a little different rate. You notice that? So this is going to be 0.05. So you get less of a rate, but it's compounded more often. So see if that makes a difference. Times t, which is 10 years. And then we're just going to type that in our calculator and see what we get. Okay. Oops. Okay, so 1,000 times 1 plus the fraction 0.05125 over 2 to the power of 2 times 10. Let's do the other one as well over here, 1,000 times e to the power of, so hit this key, 0.05 times 10. Okay, so this one we got 1,658.72, $1,600. This one we got $1,600, but only 48 instead of 58.72. That's it.